Okay, and then here's the second movie. First one, I have to split it up because I got to keep limits on the size. So I'm going to cut that into three. And then you need to, in the email, I give you this printout, all right? And you need to print this out and do the ones that I do not do. So area questions, there's page one. Um, this is not like area of a shaded region. This is just to denote what is the height of a triangle when it's obtuse, all right? And which numbers do I need to use? Well, just be aware that this represents, let's go red, the height of the triangle when you're referencing the obtuse angle here. So this represents the height. 18 is a distraction. The base is actually the actual length of the base of the triangle itself. So this is half 13 times 7. So be aware of that, how that looks. And then be aware of questions like this. This isn't find the area, this is find x. So how do you find x? Well, this is a parallelogram. Parallelogram is base times height equals a, area. Well, you're given the area. So this is the kind of question where you plug in 153 feet squared for the area, and then you're given the base, which is 17. So you need to find the height, or in this case is called x. All right? So we'll put an x there. And then you know what to do there. You divide and then you're done. Okay, I'm not doing both of these. You need to figure this one out. What is that a picture of? Finding all of that area that is shaded. Interesting. All right, because this one is find the area of the shaded region. Now this one is a little bit easier than what we had for what I showed on the PowerPoint, especially that last one. Oh, you didn't have that PowerPoint anyway, but that's where it came from. So this is rectangle minus triangle. I probably shouldn't do this one because I think most of you could have figured that out, if not all. So what is this height of this triangle, knowing that this is the base because it's a rectangle? Well, if this is 8 and this is 15, we got 7 left over. You know what? Why don't you just do that? And then we'll go, we'll just take it from there, see what you get when we get back in class. You should be able to do that one. I did a side note on what this represents as a picture. And then the same thing as this one. What is that a picture of? It starts with a K. All right. And then what is this when they say this is from here to here? Well, that is this length. What's that called? I don't know. All right. And then this length from here to here. Ooh, what's that called? I don't know for the kite. You look it up and then you try to find what happens on there. So I'm not going to do that. You should be able to handle that one. Same thing with this. This is a picture of a... Okay, you better said something that starts with a T, and I'm going to leave that one alone. But I will do this one. This is a picture of, interesting. It might be a square, it might be a rectangle. But what I do know is I have this. Interesting. What's that called? And then I have this. Interesting. What's that called? And I know these two things are what? Interesting. Diagonal. Okay, what? I meant perpendicular. These are called diagonals. Got it. So actually, since these diagonals are perpendicular, it looks like it's a square to me, which is related to a rhombus, which is, what happens. Well, let's just stop there. For a rhombus, there is that alternate formula, half d1, d2, half the diagonals multiplied together. 1, 2, 3, 4, 5, 6 by counting. 1, 2, 3, 4, 5, 6. This is a square. When the diagonals are equal, it's actually a square. So, but anyway, for a square, you can also use this formula. So, referencing that because maybe that has something to do with something up here. Just kind of, giving you little hints there. All right, so you should walk into class with this done so you and your partner can be maximized as far as how well you do in my little quiz. All right, so let's go to the next page. Right, of your printout. Not doing that one. Find the exact area. Exact. Then find the area to the nearest hundredth. That means I should have 2 answers. Okay. Ooh. All right. That little exclamation point just means degrees. So something happened there. I'll do this one. All right. And then you need to figure out how you, just little circle stuff to figure out how you get that shaded region. So again, area of the sector. So that's what this represents. So change that the exact area of the circle or sector. Well, that's what this represents, shaded region. So area of a circle is pi r squared, like I was trying to show you in the first movie. But this isn't the whole area. I want only 65 3/60ths of that area. All right? So that is the area of this sector, just this little piece of the pie. Who's hungry? I am. All right, so I'm going to hit that right there. That's my calculator. All right, and then just going to cover how you get this in exact. Divided by 360, press entry. Ooh, math, frac. I bet you wish you had that button. That's my favorite fraction, by the way. Times 16, because that's what 4 squared is. Press enter. So the exact answer is 26/9 pi. And then it is in inches, so it's inches squared. So that's the exact answer. Leaving the pi button alone and really not writing a decimal out of this, is the best way to handle that. Then times that by pi, times second pi. Now it's going to force a decimal on me. And then that is actually getting the exact, which has a little bit more real worldness to it, because we could lay out 1 by 1 inch cubes, squares. I keep saying that. And then 9 of those is about what would fit in this little area there, and then that would make sense to us. I'm not doing that next one. You should be able to handle that one. All right. All right. This one's interesting. And I'm going to tell you what all this means here in a minute. But this one's cool too, and hopefully you can maybe handle this one and figure it out, because this is starts with a C, circle, and then these are a bunch of equal whats. And actually they're sectors, so you got to be careful on that. So really, how you do this is maybe figure out this angle measure here. All these angle measures should be equal. And then what you're going to have is circle minus 1, 2, 3, 4, 5 of these sectors. That might be one way to do it. Or find the area of this sector and then multiply by 3. One way or the other, you should get the right answer. What this means is these are equal in length. So this is equal to this, which is equal to this, which is equal to this. So this one I will follow through on because this is a little bit crazy. So this is circle minus, I don't even know what that's a picture of. All right. Minimum, I'll just call it a kite because I'm a little confused. It could be a kite, it could be a parallelogram. In either case, or actually a rhombus is what I meant to say. In either case, we can use that D1 times D2, then half of that. So I'm going to call it a rhombus. All right. Yeah. Could call it a kite if we don't know that those are, because what we do know is these are diagonal. All right, so why do we, I'm sorry, I did it again, perpendicular. So that only happens in a kite, a rhombus, and actually a square. But I know it's not a square because those angles are not 90 degrees. So if this whole thing is 6 inches, then, and these are 4 equal parts, this represents that these are all 1.5 inch. 1.5, 1.5, 1.5. So I'm going to get rid of all of that. Because then what that tells me is this diagonal is 1.5 plus 1.5, which is 3. And then this diagonal is actually 6 because this is 6 all the way across. So this is 6 all the way across. Long story short, the radius of the circle is not 6, it's 3. So there's area of the circle, pi r squared, minus the area of the rhombus is half 3 times 6, D1 times D2. So there's that very popular formula there that you want to know. So this is 9 pi minus half of 6 is 3. 3 times 3 is 9. No, this does not equal pi. Don't be redonkulous. All right, that is the exact area. This is inches squared. All right, and then the approximate would be you type 9 pi minus 9 and press enter. 19.3. Let's just do 19. At least do tenth. I like to go hundredths a lot. I was just lazy on that last one. That's approximate.